Yes. Student, uh, we have already loaded the unit 4, effect of current, chapter 12, already given in the our YouTube channel. And now uh, we will study today chapter 13. So let us see, it contains 12 marks compositely for 12 and 13 chapter. Chapter 12 already discussed and given, uploaded on our YouTube channel. And today I will discuss about chapter 13, magnetic effect of current. What is the meaning of the magnetic effect of electric current? We know that through any conductors, when current flows, suppose we have a straight conductor or any kind of conductor and current is allowed to pass. What is the action of the current around the wire? It is seen that when current flows through a conducting wire, there is circular, concentric, imaginary magnetic field lines are produced. And this very productions of the magnetic field lines by the action of current passing through it. Suppose we have written here AB as a conductor and allowing the current to pass. I is the current flowing. I is the current flowing. AB is our wire. You may say it as conductor. So magnetic effect of current is the phenomenon of phenomenon of production of magnetic field around a current carrying conductor or around a conductor when an electric current flows through it. Electric current flows through it is called magnetic effect of current. So of electric current. We have seen here this very production of the magnetic field, which is shown by the circles. We used to write symbols magnetic field B vector. This very effect was first time observed by Hans Christian Ørsted, who was the scientist. Hans Christian Ørsted. Ørsted. So Hans Christian Ørsted has observed such type of the effect. Whenever current flows, there is some attractive property developed around the current carrying conductor, and this attractive property is nothing but the magnetic field produced around it by the action of current. And the scientists have invented such type of the observation in 19th century. In 19th century, It was observed by Hans Christian Ørsted. And when we put any magnetic compass just near to the current carrying conductor, we observe that there is some deflections observed in the magnetic compass needle. So compass needle get deflected when metallic conductor current is placed nearby it. Okay, so after knowing the concept of the magnetic effect of currents and the name of the scientist behind such type of the observations made in 19th century, Hans Christian Ørsted, and we will here find the concept of now we will see here the concept of the magnetic field. Magnetic field. What is the meaning of the magnetic? Magnetic field is represented by B vector, and it is actually the region of space around a current carrying conductors, uh, as well as the space around the any given magnet. Magnetic field has sense of, just think of any current carrying conductor, current is passing, and the region of space around it, you can show with the dotted lines. Yes, the region of space around a current carrying conductor or around a given magnet, around a given magnet where any magnetic material, any magnetic material gets attracted is called magnetic field. So for any bar magnet, you can also think of either for the current carrying conductor, the space around the current carrying conductors develop some attractive properties. Any magnetic material gets attracted. And when we put the magnetic compass near to the current carrying conductor, we see that there is deflection in the magnetic compass needle. And if we are taking a bar magnet for simplicity, suppose the North Pole and South Pole is located there. So field lines emerge out from the north and converge to the south, to both the side. Yes. So it is seen here the region of space around the given bar magnet or any kind of magnet. Not necessary to have the bar magnet only, but bar magnet gives very proper way of emergence of magnetic field lines and convergence of the field lines to the south pole and north pole. So around this bar magnet, when we put any magnetic material or when we put magnetic compass, we see that there is deflection observed in the magnetic compass. So actually, magnetic field is taken as B vector. We used to write magnetic field by the symbol B vector, and this very magnetic field is a vector quantity. Vector quantity has sense of magnitude and direction. Magnetic field has both magnitude and direction. It is always directed depending on the direction of the poles of the magnet. If north pole exists to the left side, then field lines will emerge from the north pole and converge to the south pole. Similarly, in the case of current carrying conductors, it depends on from which direction the current flows. So the direction of the current decides the direction of the magnetic field lines also and total field also around it. So it is a vector quantities because it has both magnitude and direction, and SI unit of magnetic field. SI unit of magnetic field is Tesla. Tesla, after the name of the scientist, American engineer Nikola Tesla. After the name of a scientist Nikola Tesla. So Tesla, write capital T as a symbol, and Tesla can be expressed in terms of force and their measurement with the current. 1 Tesla can be written in terms of 1 Newton divided by 1 ampere meter. So ampere stands for current measurement, and Newton related to the force. So 1 Tesla is 1 Newton per ampere meter, and 1 Tesla also related with the Gauss, which is taken as the CGS unit. 1 Tesla is equal to 10 to the power 4 Gauss. So this must be remembered as a conversion of one unit to other unit.